Welcome. We want to take a look at Polya's problem-solving strategy. Now, really, this is just an outline for how to approach a problem. So the outline is, if we have a problem that we want to solve, we will first need to understand the problem. Of course, definitely. Although it seems sometimes that we don't really think too much about that, and we find ourselves saying, I don't really know what's going on, and I move on anyway, because we don't even recognize that we don't know what's going on. Anyway, so we understand the problem. Then we want to devise a plan. How am I going to answer this question or solve the problem? Well, okay, I'm going to try that. We review the solution to determine if it actually is a solution to the problem. So that's the goal here. All right, so we're going to take a look at a process that will, let's see here, we should be able to discuss a little bit further later on, potentially anyway, when we talk about graph theory later on. Anyway, so what we want to do is we want to apply our four-step process. So consider the map shown here. Allison wishes to walk along the streets from point A to point B. How many direct routes can Allison take? Well, we want to understand the problem, right? So Allison can walk from A to B, but how can she do so? Can she walk along the path like this to get from A to B? And the answer would be no. And why not? Because we want a direct route. So we want to understand what a direct route means. If I were to give the option of being able to walk in a direction that is away from B, then I would have a problem. And certainly if I were to consider things like overlapping, walking in the same place like this, or going around and just simply crossing the path again, right? These sorts of things, all those aren't going to be any good for us. Every move we make has to be towards B. That's what it means to be taking a direct route. So now we understand the problem, right? So understand the problem. Okay, that's what we just discussed. Now we need to devise a plan. Well, this would be very time consuming if we were to just try to start listing all the possible paths. Here's 1, here's 2, here's 3, here's 4. And we could do this, right? We could establish this, but it's going to take quite a bit of time to do that. So rather what we would like to do is we would like to make the problem a little bit smaller. So we're going to start by redrawing, so that way we have something a little bit easier to look at, and then we're going to simplify the problem and make it a little bit smaller. What we're going to do is we're going to say, well, what if point B were just one block, not one block, but the opposite corner of a block, there we go, away. So how many ways could I get there? Well, I could either travel this way or I could travel that way. That makes the problem very simple. There's only 2 ways to get there. So this is our, we're working on step 2 here. We're trying to devise a plan to answer the problem. So what we're going to do is we're going to make the problem a little bit bigger. What if point B were opposite corner, but 2 blocks now? So we say, all right, well, there's one way to get to here, one way to get to here. So I could go this way or that way to get to here. That's 2 ways. Let's see here. Now to get to here, there's only 1 way to get there, right? I traveled there. Boom. That's the only way to get there. Right, direct routes. There's only 1 way to get all the way down here. So 1, 1. Now what I do is I say, okay, there's to get to here, I could go down and over, I could go down, over, down, I could go over and down. And those are the only possible ways to get there. So there must be 3 ways. Now what I do is I say, all right, to get to here, it's essentially the same thing, right? I can go over and down, I can go over, down, over, I can go down and all the way over. Again, that's 3 ways. Okay. Oof, we're still counting. This is still annoying, but this is still a much smaller problem than the one that we actually want to solve. So how many ways can we get to B if it were just here? Well, all right, so I've got 1, let's see here, 2, 3 ways that I can get there. Okay, so I went down and down and all the way over and then all the way over. So let's try to trace those out here. Let's maybe get rid of some of these lines so we can keep track a little bit easier. So we have 1, 2, 3. Now instead of, no, I haven't used any of these here, so I've got 3. Now I can go 4 and 5 and 6. Excellent. Yep, I believe that was all of them. So 1, 2, 3. Yep. 1, 2, 3, 4, 5, 6. Yep, 6 ways. Excellent. Oh, man. All right, but the question is, how can we generalize this? Well, the only way to get to this point here, sorry, not to that number, but to this point here, is to come from this one or to come from that one. I think we can agree with that. Excellent. So if we can agree with that, there's 3 ways to get to here, and then once you're here, there's only 1 way to get from there to there. Now here, there's 3 ways to get here, and the only way to get from here to there is the 1 way. So there's 3 ways to get here, 3 ways to get here. That means pick the 3 ways and then drop down, and then pick the 3 ways and then move over. So I have 3 plus 3 gives me the 6 total ways to get right there. So anytime I want to get to a point here, I can simply find the number of ways to get there by adding the number of ways to get to the location above or to get to the location to the left. And this should make sense for us. So then what we can do is we can start to fill in the larger generic, right? So if I go back to my generic here, well, there's only 1 way to get here, 1 way to get here. And now I can say, oh, well, I can add those 2 to find that there's 2 ways to get here. Here, there's nothing above, there's only to the left, so there's only 1 way to get here. There's only 1 way to get here, there's only 1 way to get here. And now I just start adding things together. How many to the left, how many above? 2 plus 1 is 3. 3 plus 1 is 4. Let's see here, 4 plus 1 is 5. And how many ways to get here? Well, there's only the number above, so 1. How many ways to get here? There's only the number above, 1. And I can work on filling the rest of this in. 1 way to get here, 2 ways to get there, so there must be 3 ways to get to this corner. 3 plus 3 is that 6 that we had previously found. 6 plus 4 is 10. Now here, 10 plus 5 is 15. Now here, 1 plus 3 is 4. For here, 4 plus 6 is 10. For here, 10 plus 10 is 20. And then for here, 20 plus 15 is 35. So I've applied this method to the whole thing. If we go forward a couple of slides, then we see, yes, that is precisely what they had demonstrated here. At this point, we give, so our solution, the answer that we give is there are 35 ways for Allison, I believe her name was, to get from A to B. So we have a solution. We would like to review it. Does this seem reasonable? It seems like a lot, but based on what we have, we can't find any problems with that. So, excellent. So could we devise a scheme for drawing each of those? Possibly. I would maybe encourage you to approach them in the same way that we constructed the numbers. Draw the 1, and then from here there's the 2, so draw the 2. From here there's 3, so draw the 3, draw the 3, draw the 4, that sort of thing, right? Because all you have to do is draw the 2 ways. Well, now to get however many there are here, we just have to add, in order to get to this one, we have to go to here as well. There's only 1 way to get there. To get to here, now I have, since there's 3 ways, 1 way to get to there, another way to get to there, and then down, move over, and down. So we can construct each of these in a very small way. We're just setting essentially 2 edges, 1 or 2 edges each time. All right, so that's it for Poly's method. So join me again to take a look at reading and interpreting.